since you guys are now good at solving equations, let's take a look at how we can use that to help us solve some problems in context, that is, solve some application problems. Anytime you guys come across an application problem, first things first, read the problem, read it again, and get a feel for what's going on. So in this problem, you see, okay, there's two people, they're selling these tickets. We have a total, and in fact, that should be the thing that jumps out at you. A really common scenario that we'll take a look at is, here we have a total that comes from two pieces. Namely, we have a total number of tickets, and some of those tickets were sold by one person and some of them were sold by another. Now, I'll encourage you to not immediately try to write an equation that looks like a math equation. Instead, write an equation that anybody you talk to would look at and go, okay, that makes some sense to me. In particular here, the equation I'm thinking about is, since we have a total number of tickets sold, and we know that that total comes from two sources, what we'll do is just simply say this for our statement. If I take the tickets sold by one person, namely Mark, add the tickets sold by the other person, Jacob, and I add those two things together, what I should get is the number of tickets sold. Now that I have that idea, well, now I'll go in and I'll try to fill in all these different quantities that I know. In particular, total number of tickets sold, hey, I have that. That's 80. When it comes to tickets sold by Mark and tickets sold by Jacob, I don't know those values, but I do know some information. These two are both unknown, but I do have a way here to relate them. Namely, I know Mark sold 28 more. So what I'll do is call one of these my variable. Let's call X my variable, and we'll let that represent the number of tickets sold by Jacob. And now I know Mark's total number of tickets sold is 28 more than that. So I'll take that variable and say, I want something 28 more than that. In this case, we'll use X plus 28 to represent how many tickets Mark sold. Notice we have an equation now. This is the kind of equation that we'll be able to solve. So now we'll solve it. So when we go to solve this equation, we will simplify each side. Notice my right hand side totally simplified. My left hand side, I do have two like terms I can combine. Now that each side is simplified, we will get all our variable terms on one side, everything else over to the other. So in this case, we'll subtract 28 from both sides. That leaves me with 2x equal to 52. Now we'll get our variable all by itself. So if I divide both sides by 2, that tells me x has to equal 26. Now keep in mind, if our job was just solve an equation, our answer would be the value of the variable that makes this thing true is 26. In this case, our task is to answer the question, how many did each person sell? Obviously, you don't want to answer x equal to 26. So we'll have to take a moment here and go back and answer the question. I know x has to be 26. I also know here that x was representing the number of tickets sold by Jacob. So I know to answer the question, Jacob sold 26 tickets. And I also have to look to see how many tickets Mark sold notice we used x plus 28 to represent that. So 26 plus 28 looks like 54. So we'll tell everybody Mark sold 54 tickets. And before we leave the problem, I will take a quick moment just to make sure that my answer makes sense in terms of the problem. Notice, total number of tickets sold, 26 plus 54. There's my 80 tickets sold. And on top of that, Mark sold 28 more than Jacob, because 28 plus 26 gives me that 54. So now I can confidently say, hey, there's my answer.